One thing about D, if you're working on part D, what do you always try first? GCF. You take out a 2. This whole process only works when the first number is a 1. The backside is all about what if the first number is not a 1? Oh shit. So then you're like, well, Jeff, why'd you give us 1 where the first one's not a 1? Because you could take a 2 out and then it is a 1. You always try GCF first. Alright. Let's take a look here. What two numbers multiplied by 24 had to be 11? 8, 11, 33. Yeah. If they multiply by negative 40, they have to be different signs. They had to be positive. The bigger one has to be positive. Do you guys see how that plays off each other? So if negative 40 adds to be 6. It's got to be 10 and negative 4. I like it. If they added to be negative 6, it would be negative 10 and positive 4. Now I like this one. They add to be negative 1, which means the two numbers, and they multiply to be negative, which means the two numbers have to be 1 apart from each other. Like 4 and 5, 6 and 7. In this case, it's 7 and 8. I like it. So 7. The bigger one's got to be negative. Sweet. So everybody should be able to do that kind of thing. The better you are with numbers, the easier that process is. And number sense is a lot like being able to read. If you don't read much, you won't be able to do it. If you don't use numbers much, you won't be able to use them very well. I mean, it's the same exact idea. This was just, and again, if you know how to factor these kind of things, this could be kind of tedious, but I'm trying to show you why the process we use works. It's not just something we went, let's just do this shit. No, it's because we observed patterns. That's what a huge part of math is. So when I multiply these together, I get x squared plus 5x plus 4x plus 20. So we get x squared plus 9x plus 20. The last number is the product of those two last numbers. The middle coefficient is the sum of those two last numbers. And then here you get x squared plus 2 and 8 is 10, 16. Right? Again, 16 is 8 times 2, 10 is 8 plus 2. Here you get x squared minus 8x plus 12. And here you get x squared plus 3x minus 28. Whatever. Same thing, right? That's just trying to really hammer it home. So that's why this is a necessary skill, because the pattern we observe is the two numbers that go here have to multiply to be the last number and add to be the middle number. So that's what so when I get a problem like this, I know what goes at the front, because what times what is x squared? X times x. So that part's known. What I don't know is what numbers go at the end. But you guys know. What multiplies to be 12 adds to be 8.
6 and 2.
6 and 2. Well, some of you guys are like, just shut up, Jeff, let me just say it. So part B, since they multiply to be positive, they have to have the same sign. So they have to actually add to be 12, not the difference is 12. I don't know if you guys see what I'm saying. They both have to be negative. So in this case, so x and x again, because x times x is x squared, check. Now I'm just trying to get the numbers that make it work. And what adds to be, multiply to be 20 adds to be negative 12? Yeah, negative 10, negative 2. Right, let me stop there for a second, yes? So factoring a trinomial where the first number is 1 is all about number sense. Playing with the numbers, that's what it is. Oh, this guy. Shit. And watch, let me show you something. I love my colleagues. Even my colleagues don't get this idea. It just drives me a little insane. So you're all like, oh shit, this is crazy crap that Jeff made. Normally when you're taught this, people don't tell you something interesting. You don't have to get the factors of 60 first. Right? Because there's a lot of freaking factors of 60, and it's really easy to miss the one that works. I can find two numbers that add to be negative 11 and then check to see if they multiply to be 60. Do you guys? I just need two numbers that do both. I didn't say you have to get two numbers that do one of them first. So what am I trying to say here? What's true about the two numbers? It multiplies to be negative, so they have to be different signs. Right? So that means that they have to subtract to be 11. They have to be 11 apart. So for example, 3 and 14, they would add to be negative 11 if the 14 was negative. But what is 3 times negative 14? Freaking negative 42. Nope, no good, right? And some people, what you don't realize is, you do the same thing when you do it the other way around. You went 20 is 4 times 5. 4 and 5 don't make 12. Nope. I mean, you make a little list in your head of products, of factors, and then you check each one to see what adds to be right. I'm just saying, do it the other way around sometimes. Especially when the last number is bigger with a lot of freaking factors. It's a lot easier to make two numbers that add to be 11 than it is to make two numbers that multiply 60. There's a lot of them. So then I go one step up, 4 and negative 15. And what's 4 times negative 15? Check. So then I got x for x squared, plus 4 minus 15. Real quick, just in case anyone's sitting there wondering what they're doing wrong, if you wrote this instead, are you okay? Of course you're okay, because multiplication doesn't give a shit which order you do things in. 8 times 6 is the same as 6 times 8, right? So please don't sit there thinking, why is the 4 first? Oh, no. I always have somebody that's doing that. All right, now this is the one that I gave you that little hint about. You can take out a 2. And what's the only numbers that add to be 4 and multiply to be 4? 2 and 2. So you can stop right there, that's fine, but you can actually make this 2 times x plus 2 squared. Either way. So I would take that, or I would take that. They're both right. What about part E? Remember that thing I said earlier about if they add to be a 1 of some kind, that means they have to be 1 apart. So what two numbers are 1 apart and multiply with 72? 9 and 8, I like it. Which one's got to be negative? The bigger one, so that it comes out to be negative in the end. A minus 9, A plus 8, bam. How do you check yourself for all these? Multiply them out. Yeah. And then finally, my favorite one. I mean, it's really quick sometimes, most of the time, to see that it's just not going to work. The only factors of 7 are 7 and 1. Any way you can put those together, make 3? No, so it's prime. Please understand that in the homework, on a test or a quiz, I'm not going to have more than like 1 or maybe at the most 2 that are prime. So if you're putting prime on every other problem, you are not trying hard enough. You understand? No, it looks prime. Prime. So be careful about that. There will be some that are prime, but not all of them. Okay. Oh, cool. Not too bad. So here, let me show you an example. Let's show you another example of what I'm talking about. So let's say I had, what you got, Jeff? Ooh, I like it. See, what my colleagues do, and I love them, and the reason they don't think my way is smart is because what they do is they make a complete list of all the factors of 340, and then they check each one to see if they add to be 3. Well, that to me is insane. And so when I said, why don't I find numbers that add to be 3 and check to see if they multiply with 340, they're thinking, well, that list would be infinitely long, Jeff. There's an infinite number of things that add to be 3. Well, that's true, but why would I do that kind of shit? It becomes a Price is Right game. What do I mean by that? You guys know the Price is Right? Yeah. That's what I watch when I'm sick at home. what's got to be true with the two numbers? They have to be the same sign or different signs? Different signs. So they have to be 3 apart. So, for example, just to get the ball rolling, like 20 and 23 are 3 apart, right? If I made 20 negative, wouldn't they add to be 3? Is that true?
Yes.
Now, what are they supposed to also do? Multiply to be negative 340, but these multiply to be negative 460. Oh shit, too high. Too high. So I got to go a little lower, right? So why don't we try negative 18 and what? To make 3. 21. What's negative 18 times 21?
378.
Negative 378. You're getting closer. Do you guys understand what I'm saying? Do you guys see what I'm saying? Now, I'm not saying that you can't start with 340, make a list of factors. That's completely fine. I'm just saying that could take for frickin' ever. This way, it kind of hones in on the answer kind of quickly for you. So let me go down a little bit further. Why don't we try negative 17 and 20? That makes 3, right? And what's negative 17 times 20? Negative 3 freaking 40. So what's the answer going to be? X squared is x times x, and I got my two numbers, minus 17 plus 20. Kabam. So much better to make this long-ass list of factors of 340. No thank you. Okay. I think that's plenty for today. So, just if you're going to the lab, maybe just saunter over. I don't want to invade an enemy space too early. Right? Yeah. This is so nice. If it was me, I'd be like, get out of here.